Hai. Okay, so bertemu kita sekali lagi. Okay, kali ni Madam Kis nak ajak you all untuk describe the oxidative phosphorylation. You all dah dengar penjelasan yang panjang lebar berkenaan dengan oxidative phosphorylation. Jadi sekarang apa kata kita cuba untuk terangkan dua proses utama dalam oxidative phosphorylation, iaitu ETC dan chemiosmosis, dengan air yang lebih ringkas, dengan lebih mudah, cepat dan padat. So I'm going to demonstrate it to you, and after this video I hope you will able to try yourself to explain. And finally, feel free to share your video through my Flipgrid, and I'm going to give you a link. Alright, so let's do some revision together. So about the electron transport chain. So there are 4 main guides that you have to follow, and how about we try to use the simplest sentence and use about 6 to 10 sentence only, simple sentence to explain the process. Okay, let us start with the first one. Oxidation of NADH until how H plus is pumped, by using the energy released by that NADH. Alright, so the first sentence, NADH undergo oxidation forming NAD plus, H plus and 2 electron. Number 2, electron produced is transferred to complex 1, NADH dehydrogenase, causing NADH dehydrogenase to be reduced. Point number 3. Next, electron from NADH dehydrogenase is transferred to series of electron carrier complex embedded in inner membrane of mitochondria, such as ubiquinone, cytochrome C reductase, cytochrome C and cytochrome C oxidase. Number 4, series of redox reaction occur along the EPC. Point number 5, electron from cytochrome C oxidase is transferred to oxygen that act as last electron acceptor. Next point, oxygen will combine with H plus ion to form water as byproduct. Next. The next point is, during the electron transfer, energy is released. And the last point, energy is used to pump H plus ion from matrix of mitochondria to intermembrane space. Each NADH able to pump 3 H plus ion via complex 1, complex 3 and complex 4. Simple, right? How about FADH2? The story is the same, but you just focus on the pathway that FADH2 pass through. So we start with FADH2. The first point, FADH2 undergo oxidation forming FAD, 2H plus and 2 electron. Point number 2, electron is transferred to complex 2, succinate dehydrogenase, causing succinate dehydrogenase to be reduced. Point number 3, succinate dehydrogenase will transfer electron to series of electron carrier complex molecule such as ubiquinone, cytochrome C reductase, cytochrome C and cytochrome C oxidase. Point number 4. series of redox reaction occur along the EPC. Point number 5. Electron that reach cytochrome C oxidase is passed to oxygen that act as last electron acceptor. Point number 6. Oxygen will combine with H plus ion, forming water as byproduct. Point number 7. As the electron is transferred along the EPC, energy is released. Point number 8. Energy release is used to pump H plus ion from matrix of mitochondria into intermembrane space. Okay, point number 9. Each FADH2 able to pump 2 H plus ion via complex 3 and complex 4. So that's it for EPC. Okay, and let us continue with chemiosmosis. So when all those H plus ion is accumulated at intermembrane space, okay, how that concentration of H plus will create or synthesis ATP, okay, and it is involved, okay, the structure of ATP synthesis that is embedded in inner membrane of mitochondria. And so we are going to focus on these 4 main things. Okay, the first one is characteristic of inner membrane of mitochondria. Okay, how proton motif force can be created. Okay, the third one is how H plus ion able to flow back from intermembrane space into matrix of mitochondria. And finally, okay, how ATP can be synthesized. Okay, so same as the previous rule. So we try to explain by using simple sentence. Okay, not more than 10 points. Okay, I will try to use just 5 points to explain this chemiosmosis. Okay, let us try. Okay, the first one. Okay, inner membrane of mitochondria is not permeable to H plus ion. Point number 2. Accumulation of H plus ion at intermembrane space will create proton motif forces. Point number 3. Proton motif forces will force the flow back of H plus ion from intermembrane space into matrix of mitochondria via ATP synthesis. Okay, point number 4. The flow of H plus ion through ATP synthase is exergonic reaction that release ATP. Point number 5. Energy release is used to phosphorylate ADP, okay, to form ATP. So that is how 10 NADH and 4-FADH2 produced during glycolysis, ring reaction and Krebs cycle is harvest, okay, dituai untuk menghasilkan lagi 34 ATP secara oxidative phosphorylation. Hope it can give you motivation to memorize and understand, okay, the process of oxidative phosphorylation, and finally, okay, allow you to master the concept and able to answer the question, okay, correctly during examination. Hope it helped you. Okay, until then, Assalamualaikum.